Okay, well, welcome again to this foundation engineering. I will be starting. I have in few lectures. I have covered the just to review the soil mechanics. Now, I will start foundation engineering with introduction of foundation engineering, and you can see that the foundation engineering means what actually. This is the applying mechanics, then geology and construction experience to gain insight into how soil responds, so that soil engineering systems can be a civil engineering system can be built and will perform satisfactorily. So, this is the foundation engineering key goal. Okay. So, you have to see apply mechanics, geology and construction experience, past experience, somewhere some already done, from there some difficulty or etcetera, whatever happened. Based on that experience, we will learn something, and based on that we show that we can civil engineering system can be built and will perform satisfactorily. That is actually nothing but foundation engineering. Now, under this foundation engineering, as I have covered that this is foundation engineering will be covered in various steps. You can see the first step in the is understanding project and site, and then develop design. Understanding project and site means what for the project and the location, etcetera. You have to understand first, and then develop design criteria. That means different design criteria. That means somewhere you have to restrict certain settlement or sometimes some pressure. So, those are all different design criteria that has to be used. Identify possible foundation alternatives. That means there may be several options, but finally, you have to pick up the suitable one. Then you have to soil investigation you have to carry out. That means, you have to know the detail about the soil. In fact, sometimes soil investigation may be done before selecting the foundation type. Then you have to, after soil investigation, you have to characterize the site. That means, whether it is what type of site it is. Then engineering analysis to evaluate alternatives. Then real analysis has to be done to evaluate the alternatives. Then develop recommendation right report. That means, finally, after doing that, you have to give a report and recommend that this type of foundation is suitable, this area or similar type of things. And then finally, after doing that, you have to monitor design, construction and performance. That means, while doing this, while designing, you have to monitor whether is there some anything goes wrong, and then during construction also you have to have monitor, and also after construction also you have to see how it is performing. So, all those things to be considered in foundation engineering. Then understanding the project and site, under that what you should look for. This is the one, actually you can see that project intent. That means, if you get a project, then you have to know what is the project. That means from the owner, actually, whether it is a residential building, whether it is a commercial building, and whether it is something else, that project intent first to be learned. Then assess general soil and site condition. That means, how you will get that from the previous borings, maps, reports, nearby structures, etcetera. Then previous experience in the area, that means adjacent structure, how it was constructed, how it performed, that has to be also investigated, or you have to report. If there is any report, you have to see and evaluate them. From there, you can use your experience to the next project. And then constraint, that means local building codes. Sometimes there are building codes will vary time to place to place. So, you have to see those codes. Then neighboring facilities, access issues, economic limitation, all those things to be seen under understanding the project and site. So, these are the points you have to look for. Next part is develop design criteria. Under these, actually there are several things. What are those? First thing is allowable settlement. That means, when you construct a building or develop a facility that on the soil, then the building definitely will undergo settlement. I have already explained in the soil mechanics and even in the review that if you build something on the soil, then because of the compressibility property of the soil, the building will settle. and that settle we cannot allow any amount. So, that there is a limit. So, that is one thing, allowable settlement you have to see. Then acceptable factor of safety. So, factor of safety actually is a term that is the ratio of two things, and different project different factor of safety is demanding will be demanded, and so accordingly you have to see what is the type of work and what value of factor of safety can be used, that has to be seen. Then identify constructability issues, that means in a particular area some method may not be able to apply. So, that thing you have to see. Then obtain design loads, that means what are the different source of loads. Building loads always obviously will be there, there will be living load, live load will be there. In addition to that, there may be wind load, there may be earthquake load, there may be some other loads. So, that has to be seen, and then finally, you have to refer the building codes for designing. So, you cannot do just like that application of mechanics. In addition to that, considering the material behavior and many other things, people have given some recommendation in the form of code that has to be used for the design. And next part is the under this settlement, as I mentioned just settlement. Settlement again can be of three different types. You can see this is a settlement where the entire building is settling uniformly. It is not that much harmful. If it is little higher value, but still it is not harmful, because building is this is settling uniformly. Whereas, this settlement is called tilt, that means one side is settled more than the other side, then that is called tilt. And this tilt actually sometime is harmful, that I will come later on, and this is another type of settlement. You can see that this is actually tilt, actually what this can be different amount, it can be this side no settlement, this side a settlement, because of that also tilt can happen. And this is another situation where this is called differential settlement, because different places settlement is different, and because of that building may develop cracks and all, that is the thing is shown here also. So, these three types of settlements are there: settlement, general settlement, then tilt, and then differential settlement. So, different type of settlement will have different limiting value, that has to be seen and considered during your design. And you can see that allowable settlement for your office building, it will be sometime 12 to 50 millimeter. In our code, if you see value may be different, I am just referring a average value. 25 millimeter may be the most of the time is common value, and heavy industrial building the settlement can be allowed little more, it is 25 to 75 millimeter, and bridges generally settlement limit is 50 millimeter. Similarly, tilt and differential settlement, why it happens actually, there are a number of issues. You can see non-uniform site condition, that means building is constructed over a site, one side is better, other side is not that good. In that case, one side settlement will be more and other side will be settlement will be less, and that will cause non-uniform settlement. Then ratio of actual design load differs over structure, that means while designing you have considered certain amount load, but actually in the functioning time load is different, then it will have some differential settlement or tilt. Ratio of dead load to live load if differs from the structure, that also causes some tilt and differential settlement. Building dimension differ from plan dimension, actually you have designed certain dimension, but finally while construction it differs a lot, in that case also these things can happen. Similarly, effects of differential, what are the different effects of differential settlement? As I have told you, the differential settlement is the harmful, the stress in the structure. So, if the building is there, if it settled like that, if settled this side, then automatically there will be extra stress on the building elements like beam, column or wall, and then automatically there can be a cracks and there can be architectural and structural damage. And then what is the effect of tilt? Tilt also will have some effect, and you can see that first thing is uncomfortable feeling. If you see that the building is tilted like this, you will feel very uncomfortable, you will get scared to reach too close to that building. Anytime there will be feeling that it may fall, it may not fall always, but if it exceeds certain value then only it will fall. But if there is any minor tilting is observed, then automatically you will have uncomfortable feeling, and then of course, this tilting is too much, then there will be lack of stability and it may finally fall also. So, that actually because of that this tilt, differential settlement and settlement all should be considered while designing. And this is the tilt example we have given. And then next is the develop design criteria. So, next step I have shown the number of steps, and projects understanding project is one, and then design criteria, develop design criteria under that, then I have shown the settlement, and next is the factor of safety. And this factor of safety, what is the meaning of factor? Factor of safety is the capacity divided by demand. Capacity means what? The soil will have capacity to bear certain stress. So, that is actually soil capacity, and whatever demand means what? If I build a structure and then because of that soil will be stressed, and that stress actually has to be resisted by the soil, and that stress is because that become demand. So, that stress should be smaller than the capacity of the soil, then only it will be stable. Otherwise, if your demand is more than the capacity, then it will collapse or failure will occur. So, that factor of safety will be another issue which has to be considered carefully, and typically this factor of safety generally 2 to 3 for foundation engineering, whereas for slope and other wall generally 1.5. So, these are the values, recommended values what you have to use during design step. Next is a factor of safety. Again, factor of safety depends on many things. You can see here the required reliability. So, the acceptable probability of failure, that means the factor of safety you are by calculation you are giving factor of safety 2, but in the meantime in the soil parameter itself, if you have some error, then you are not able to assess the value properly. So, that means how reliable that. So, that is another issue to be seen, that when you will make the ratio of capacity by demand, and while estimating the capacity while estimating the demand, if there is an error, then that value will not that number will not have any significance. So, because of that you have to have certain reliability, that means how reliable your data, how reliable your calculation, that has to be you have to make sure. Similarly, consequences of failure, that means you have to understand that if failure occurs, what are the consequences? There is big loss, that has to be kept in mind, and because of that if necessary you may have to adopt little higher value of factor of safety. Then uncertainty in soil properties and applied loads, this is also sometime as I have told you uncertain. So, you have to do little bit of reliability to make sure what will be the value. Then construction tolerance. So, difference between design and build dimension, sometime how much difference you can permit, that has to be there. Ignorance of the true behavior of the foundation, sometimes you understand the soil may behave like this, but that soil may contain something else. So, you do not know the behavior, in that case also something may go wrong. So, you have to also take care of that, and this is a spelling mistake, actually cost benefit ratio of additional conservation in the design. That means, if you always if you want to see that the economic, but if you add little cost, what will be the benefit. So, that should be seen, and you have to make as far as possible the structure safe and serviceable. Similarly, factor of safety will be uncertainty in the soil properties into significant more risk. Then foundation failures are typically costlier than the failure in the substructure. If the substructure some portion is failed, sometimes you can rebuild, but if the foundation failed, then the entire thing to be built. So, that has to be kept in mind. So, because of that sometime you need to adopt little higher value of factor safety while designing geotechnical structures. Then construction tolerances foundation are wider than those in superstructure. That is also you have to make sure that you can accept, and extra weight on the superstructure, increase loads on the below members, that is also sometime make a little bit of unreliable. So, that also has to be considered while calculating factor of safety. And next is develop design criteria, and under this you can see there will be allowable settlement and tilt I have discussed, acceptable factor of safety I have discussed. Now, identify constructability issues, that means what way you can identify those. Sometimes the site is such that you will not be able to reach with heavy equipments, that is one issue. Sometimes soil type is something you have designed something, but the soil type is not permitting that, then you have to reassess and try to find out a proper foundation type. So, these are the things under identify constructability issues, and finally, you decide that what are the things will not permit, and accordingly you modify that and do the design. And then finally, obtain design load, you can see under this obtain design load, you can see the building will have when you construct a facility, you will have the self weight of the building first. You can see that this is, if this is a foundation, then and this is a column, its self weight obviously will be there. In addition to that, this column will bring the load from different sources like beam, there will be beam, and then a beam will support the slab. So, slab load will come to the beam and beam load will be the coming to the column. So, like that, if there are several floors, so from each floors the entire dead load will bring to the foundation through this column. And in addition to this, there can be several other types of load. There can be horizontal load, you can see horizontal load in this direction, horizontal load in this direction, two horizontal load can be there. And again there can be, because of this loading is not through the centroid of the footing, in that case you may have the moment, and this case if there is a two axis, the moment can be in this with respect to this axis, again moment can be with respect to this axis. So, there will be moment this and another moment is this, both can be there. And in addition to that, which will be generally uncommon, may not be there always, that is actually your torsional load. That means your sometime there is a building, and I will explain the torque with respect to a rod. If I apply a load actually like this, then this will have a torsional load. Similarly, building foundation can have also torsional load because of some reason, because of some special situation. So, all those things to be considered, and finally, you have to design for the foundation. And so, that means you need to know this is actually all vertical loads through self weight of the building or live load from the building, and then torque load. Then there will be couple, actually two types of couple, that will with respect to this axis, with respect to other axis, and there can be horizontal load from this axis, and this source of horizontal loads are generally wind, and both to be considered. Similarly, earthquake load also can be horizontal load, this will come as a thrust, and so that will be also will be sometimes it will be vertical load, horizontal load, both will be there. So, all has to be considered while designing the foundation, and this foundation actually what you have to design finally, it will have a definite capacity, soil will have definite pressure resisting capacity. So, you have to find out the first area of the foundation in such a such that the total load including all moment, torque, the stress at different point below the foundation should not exceed the capacity of the soil. So, that is one thing to be estimated, and then another thing to be estimated, or another thing, or another two more things to be found out. Another is that what should be the thickness of the footing. This thickness of the footing means what actually, see, if there is a column is there at the center, and from the bottom there is a uplift pressure, and in that case what will happen with respect to if I can assume that the footing just inverted one, if I just invert this one, I can assume that it is supported like this, and this cantilever portion is loaded by the soil pressure. In that case, that it will bend like this, it will bend like this. So, structure will bend. So, that to resist that bending moment, you have to find out the reinforcement required and thickness to be required. So, that to be designed as a geotechnical engineer. So, finally, you have to give the reinforcement, you have to decide what is the thickness, what should be the dimension to make sure that it should not exceed the bearing capacity of the soil, and also it should not bend, it failed because of the bending or shear. So, these are the total things to be done. This is of course, a simplest job for geotechnical engineer, that is a design of isolated footing, and more other type of work which are there, that all more complication will be there, we will discuss one by one. So, this is under your develop design criteria. There are number of things, as I have told you, that you have to see, and then finally, while as I have told that you have to find out this dimension, and then you have to find out the thickness, you have to find out the reinforcement, and while doing this calculation, again you can apply mechanics definitely, but only application of mechanics is not permitted. You have to refer the code. Why? What is the meaning of the code? Code actually will study on different materials and they see the performance, and based on that they have given some recommendation, and you have to use those recommendation. Finally, you have to provide the dimension. Suppose based on your calculation, a footing size came suppose 0.75 millimeter by 0.75 meter by 0.75 meter, but such a small footing sometimes code may not permit. So, code sometimes may give that minimum size of footing should be 1 meter by 1 meter, then you have to go for that, though it is not required as per calculation, but as per codal provision you have to do that. So, that is the importance of the code actually. So, based on various studies on material and soil material behavior and all those things, that we have civil engineering particularly, all design has to be done as per code, and that codal provision has to be applied properly, and finally, you have to suppose you have to give reinforcement, you have got certain amount of reinforcement, but code mentioned that for this you need minimum this much reinforcement, this many number, this is the minimum diameter. It may not be required as per calculation, but still you have to give, that is called a building code. So, all building codes as per building codes, finally, you have to do all calculation, and finally, you have to provide as per building codes. So, that is all today. With this I'll just introduction, still there are several steps I will discuss in the next lecture, that what are the other steps, what is their importance in the part of as a part of introduction I will cover in the next class. Okay, thank you.